Hey class, welcome back to day 2 of e-learning. You guys did a great job with the day 1 notes and completing your IXL. Here we go with day 2. All right, so today we're going to be adding and subtracting polynomials. All right, so here we go. Some big ideas for today's notes are going to be right here in this box, right? So here we go. The big ideas are when we add or subtract polynomials, we only combine like terms, right? And like terms have to have the same variables and exponents. All right, the other big idea is that exponents are not added together. All right, just like the other day, if you're able to print out a hard copy of the notes and follow along, that'll be best. But again, if you don't have access to a printer or can't print these out, that's okay as well. Just get out a sheet of paper, kind of follow along and put these notes in your binder when you're finished here. All right, so let's get to some example problems here, all right? First things first, let's read these directions, all right? So when adding polynomials, all right, we want to simplify the following polynomials by adding, and then we're going to write our answers in standard form. And again, remember, standard form is written when we have our terms are going from the highest degree to the lowest, meaning our highest exponent term first, then our next highest, and so on. All right, so number 1, we have 2x squared plus 3x plus 5x squared plus 9x. All right, so when we're doing these problems, we need to scan our problem, all right, and find our terms that are like. So as we can see, we have a 2x squared term here, and we're adding a 5x squared term to it, right? So if you remember in class before we went on break here, Mr. J did a nice job of saying, like, this is like the apples and oranges scenario, right? These x squares, we could imagine there are apples, right? So 2x squared plus 5 more x squares, or 2 apples plus 5 apples is going to give us 7 apples, or 7x squared. All right, and then scanning this problem, I see a positive 3x here and a positive 9x there. Again, those are like terms, so I can put those together. All right, so 3x plus 9x is going to give me 12x. All right, and I know that I can't add a 7x squared with a 12x because they are not like terms. They don't have the same exponent. So this is my final solution. And it is in standard form because I have my x squared term first, followed by the term with an x to the first power. All right, let's look at example 2 here. Here we have 5x plus 10, and we're adding that to 3x minus 7. All right, again, we're going to scan the problem and look for like terms, and we want to put the terms with the highest exponent first. All right, so we have a 5x here, and we're going to add 3 more x's to it. Right, well, so 5x plus 3x is going to give me 8x. All right, and now I'm going to look for my next like terms. All right, I see a positive 10 here, and I see a minus 7 or a negative 7. All right, I'm going to add those terms together. So 10 plus a negative 7 is going to give me a positive 3. All right, and you are encouraged to use a calculator when we're doing these problems here. All right, if you don't have a fancy calculator at home, that's fine. All right, your calculator on your phone will work just fine for these types of problems. All right, so now let's scroll down, just a couple more of these practice problems. All right, oop, not too far there. All right, so example 3, we have 9x squared plus 7x. And we're going to add x squared minus 5x. All right, again, we're going to scan for our like terms. I see a 9x squared here, and I see a x squared here. All right, so if you recall, if a term is just by itself with no number in front, there's really like that invisible 1 out in front, right? So this is really saying we have 9x squared plus 1 more x squared. Well, 9 plus 1 will give me 10. So then we have 10x squared. And then I also have some other like terms that I can combine here, right? I have a 7x and a negative 5x or a minus 5x, right? So I can combine those together because those are like terms. So 7x minus 5x is going to give me a positive 2x. And these terms cannot be added together again because this is an x squared term and this is just an x term. So this is my final solution, And it is written in standard form because my highest exponent term is first. All right, so why don't we pause the video now and you guys try number 4 on your own. And we will compare answers here. All right, so on number 4, we have 6x squared plus 3, and we're going to add 2x squared minus 2 to that term, to that polynomial. All right, so we have 6x squared here. We have plus 2x squared, right? Those are like terms, so I can definitely combine those. Well, 6 plus 2 will give me 8. So we get 8x squared. And let's see, we have a positive 3 with a minus 2, right? Those are just a constant term or just numbers, so I can combine those as well. So 3 plus a minus 2, or 3 plus a negative 2, will give me a positive 1. Is that what you got? I'm sure you did. All right, so now we're going to get a little more challenging here. As you can see on problems 5 and 6, right, we have some more terms in here. All right, but that's okay. We're going to move through this systematically and combine our like terms, and we'll get our final solution here. All right, so number 5, we have 5x squared plus 2x plus 7, and we're going to add 2x squared plus 9x plus 6 to it. All right, so let's do this. So we have 5x squared, and I see a 2x squared, right? Those are both my x squared terms, so I can combine those, right? So 5 plus 2 gives me my 7x squared. All right, I see a positive 2x here. Scanning, scanning, I see a positive 9x there. Right, again, those are like terms. I can combine those. So 2x plus 9x will give me a 11x. All right, I also have another set of terms here that are like, right? I have a positive 7 with a positive 6, right? Again, I can just add those up. These are all positives, so I get a positive 13. Right, and this skill we've done before. We've combined like terms before, so that's not really nothing new. Just looking at it a different way. Okay. All right, in our last example here for adding, we have 3x squared plus 4x minus 1, and we're going to add to that 2x plus 7. All right, again, we always want to start by looking for that highest exponent of the term, or the term with the highest degree. All right, so when I do that, I'm scanning here, I see a 3x squared, but I don't see any other x squared terms. Okay, that's okay, so that means it just doesn't get added to anything, right? So then I'll just drop that down. So we get 3x squared. All right, and now I'm going to look for my next highest degree term, right, which are going to be my x terms here, right? So I have a positive 4x plus 2x, so that would give me a positive 6x. All right, and I have a couple more terms left here. All right, I got a negative 1 plus 7. Well, negative 1 plus 7 is going to give me a positive 6. So now my final solution is 3x squared plus 6x plus 6. Awesome. All right. Now we're going to talk about subtracting polynomials. All right. Subtracting polynomials are very similar to adding, except for one kind of key idea. All right. So we have to be careful. We have to make sure we are reading the direction and looking at the problems here. All right. So the directions say to simplify the following polynomials by subtracting. And notice how subtracting is bolded for us here. All right. And again, we want to write our answers in standard form. All right. So we have 7x squared plus 6x, except now we're going to subtract 2x squared plus 3x from that. All right, so here, make sure you're paying attention to this step here. All right, so when we're subtracting polynomials, we have to distribute this minus sign. All right, that means that all the terms that come after that minus sign are going to switch signs. All right, so when we're doing these problems, it's going to be best that we drop our parentheses and rewrite the problem. All right, we didn't have to do that with adding because nothing got changed when we added. All right, however, when we're subtracting, things are going to change. All right, so My 7x squared plus 6x, that does not change, right? That is not affected by this minus sign. My minus sign only changes things that come after it, all right? So this 2x squared is now going to become a minus 2x squared. And this positive 3x is now going to become a minus 3x. All right, again, this minus sign is only changing the signs of everything that comes after it. All right, so now that I distributed that minus sign, now I can do what I did above with my adding like terms, right, or combining like terms, right? So this 7x squared goes with that minus 2x squared, right? So 7x squared minus 2x squared gives me a 5x squared. All right, and this positive 6x goes with this minus 3x. I can combine those, so 6 minus 3 is 3, so then that's a positive 3x. All right, and again, this is an x squared term, and this is an x term, so those don't go together. So that is my final solution in standard form. All right, let's try number 8 together here. All right, so number 8, we have 5x plus 10 minus 3x minus 7. All right, again, these problems look very similar to adding, all right, except of this minus sign right here. Okay, and if it's minus sign for subtracting, we have to add this extra step here on distributing our minus sign. All right, and again, the stuff beforehand does not get affected, right? So 5x plus 10 stays 5x plus 10. But now this is where things change, right? This positive 3x is going to turn into a minus 3x. And this minus 7 is now going to turn into a positive 7, right? Because minus a negative is a positive. All right, so now that we changed our signs of everything that came after our minus sign, now we're ready to combine like terms, right? 5x minus 3x gives me 2x. And a positive 10 plus 7 is going to give me a positive 17. So my final answer is 2x plus 17. All right, so why don't we go ahead and pause it now if you want and try number 9 on your own. All right, I'll give you a minute here to do that, and then we'll compare answers again. All right, so let's see what you got here. All right, again, this is a subtracting polynomials, so we have to distribute that minus sign and rewrite the problem. So this turns into 8x squared plus 6x. Now we're going to minus x squared, and that 5x is going to become a minus 5x. All right, so now that I distributed that minus sign, now I can combine like terms. I have 8x squared minus an x squared, right, or really a 1x squared. So 8 minus 1 gives me 7x squared. And again, notice I don't touch those exponents, they stay the same. All right, and then we have a positive 6x with a minus 5x. So, switch colors here. All right, so those terms can combine. So a 6 minus 5, well, that's going to give me a positive 1x or just a positive x. Hopefully that's the same answer that you guys got when you practice this. All right, and our last problem here, number 10, we have 6x squared minus 3, and we're going to subtract 2x squared minus 2 from it. All right, again, this is the subtraction one, so we're going to distribute our minus sign first. All right, we drop our parentheses, and I don't change any terms before it. I only change the terms afterwards, right? So this turns into a minus 2x squared, and this minus 2 is now going to become a positive 2. All right, and now I'm ready to combine some like terms. You have 6x squared minus 2x squared. Well, 6 minus 2 gives me 4x squared. And we have a minus 3 plus 2. Well, a negative 3 plus 2 is going to be negative 1 or a minus 1. All right, so our final solution is 4x squared minus 1. Great job.